All right, so we're gonna start with PIM Multicast Boundary. I will take care of the presentation part, and then Daryl will run through the demonstration, right? So what is the agenda? A quick overview, right? We'll take a look at the use cases, details and caveats, the configuration, some of the best practices, key things with regards to troubleshooting, and then Daryl will take over for demonstration, show you guys some of the configuration and and testing our multicast boundary, and then some additional resources. All right, so then overview, right? So what is basically our PIM multicast boundary? Well, this feature helps us create a multiple PIM domains by filtering MSBSM messages in order to restrict or allow specific multicast traffic across domain. Well, so let's say we have our two domain here in our example. To give us a better control over network and prevent unwanted multicast traffic flows across boundary based on the policies that our network administrator will define. Let's say domain 2 has receivers. Although we have source multicast and rendezvous points, we don't want our rendezvous points from domain 2 to be known within domain 1, and also our source multicast to be known by domain 1. But yet we want to receive multicast stream from domain 1 from specific maybe source 10.1.10, and by leveraging the PIM multicast boundary, specifically these two feature new commands, PIM sparse mode BSR boundary and multicast boundary access list, will give us this control over what we can make available to our other between the domains. Now, we'll talk more details of that, but this is just a high level, right? To give administrator a control over what multicast traffic we want to make it available between the boundaries. Now, this could be a large enterprise with multiple domains that they have based on geographically broken, or actually between multiple different entities, right? Corporates. So multicast boundary, two things to keep in mind here. First thing first, the BSR boundary. What is the purpose of the BSR boundary? This feature again helps create multiple PIM domains by filtering PIM-SSM messages. Specifically, basically, this is the PIM RP advertisement and registrations will not be exchanged across our domain, right? So this way, each domain will have its own RPs. And then with boundary access lists, well, okay, so then they don't know about each other's rendezvous point and what streams of multicasts we want to make available, and that's where the boundary access list kicks in for us to restrict or allow specific multicast data traffic across the domains, right? And prevent routing of multicast traffic on the boundary interfaces. Well, as far as being your PIM control messages being joined, for example, or IGMP membership reports. So on the boundary access list, we can match based on asterisk, comma, group flows, or source, comma, group flows, subnet protocols, and also we can have 128 access list entries are supported per ACL. Now, what type of interfaces can we configure these features? On our routed ports, L3 lag, point-to-point SVIs, right? And sub-interfaces, specifically 8360 in that case. So which platforms support this? The 6300 series, the 6405, 6410s, for example, the 8320s, the 8325s, 8360s, the 8400, and the 10,000 switches. Let's take a look at some of the use cases, right? We'll keep building in here. The use cases we'll talk about, and then we'll talk a little bit more in detail of this operations. But first thing first, Before we move a little bit further, let's do a quick recap, a review. Although MSDP was covered in previous TOIs, just to recap, make sure everyone's on the same page, what is MSDP doing for us? Well, first thing first, MSDP has two deployment scenarios. One is for inter-domain, inner-domain scenario. One is intra-domain. Let's take a look at the intra-domain. For example, we use MSDP, Multicast Source Discovery Protocol. So when I have a, let's say in domain 2, I have an Anycast rendezvous configured. You notice here, two of my devices, being my routing switches, they're acting as Anycast rendezvous, and they are sharing the same IP address, the same IP for their rendezvous announcements, right? Advertisements. Now, so to make sure that they are aware of each other, that's where MSDP is used for intra-domain, right? And what is Anycast rendezvous doing for us is providing load sharing and redundancy for our rendezvous points. Now, so between domains, right? Between domains, we will configure MSDP, will allow multicast source for a group to be known to all rendezvous points in a different domain, right? And also, as far as the rendezvous points running MSDP will exchange the source information with MSDP enabled rendezvous in other domains. And this gives us also allows us filtering. Now, if I want to make this source, multicast source available to maybe domain 2, domain 3, the rendezvous point that is running MSDP with other domains will exchange that information using our MSDP source active cache messages. So when you run MSDP within the domain, it is fully matched. And as we said, for any cache rendezvous point, right? And then you're running MSDP between of course, between the domains, inner domain. Now, let's take that and build a little bit more on top of that, right? So that was just a quick, in a nutshell, with regards to MSDP. What is MSDP doing? It is a must mechanism for us to achieve basically communication as far as multicast, if you want to share multicast traffic across the domains. Because let's combine MSDP and boundary operations. Well, we said here, I have in domain 2 Anycast rendezvous points. So I'm going to enable MSDP mesh, right? So they know about each other, which provides load sharing and redundancy of rendezvous point. Fair enough. And then we said with regards to, and then we're running MSDP between the domains. But if I don't do that, let's just say, if I'm running my multicast boundary, and on this border edge switch, routing switch, I filter BSR boundary command. I enable that command, which basically prevents domain 1 from knowing about my rendezvous points. Fair enough? And then I use the boundary ACL to filter out the source and all the joint messages and so on. Or maybe I just want to allow all my receivers, if it's the source of the multicast is 10.1.10, I would allow that. So the boundary, BSR boundary, is preventing the PIM announcement and registrations, and the boundary ACL is preventing all these other receivers to know about other sources within domain 1. And vice versa, in domain 2, I configure on the edge the BSR boundary command, and then the filter to only allow this source to be known by other domains. But the question is, how are they to know now? How is domain 2 going to know about the source in domain 1, 10.1.10, if we're basically preventing the rendezvous announcements and so on across? That's where basically the MSDP kicks in, right? So we said, of course, with regards to our internal MSDP mesh is running for the Anycast, but between intra-domain, we have MSDP, And now MSDP, using MSDP, our rendezvous point from domain 1 will announce basically MSDP source active cache messages are sent. So then domain 2 knows about the multicast source within domain 1. And when the receiver joins, for example, that join, and we will allow that request for that receiver to go across, and the multicast stream from that specific sources that we allow can flow across the domain. And yet both domains do not know about each other's rendezvous points, meaning the other PIM speaking routers, right? Only the rendezvous points that are running MSDP are exchanging that information across the domain, which is gives us that flexibility, right? Details and caveats. So solution 1, boundary on VSX with routed port only interfaces. In this solution, all we're describing basically, again, the same case, we have VSX running and the rendezvous points, Anycast rendezvous point in domain 2, right? And then being our edge, BSR, R4, and then R5 is the routed port here between the domains connection. And then on top, we have fully matched because we have Anycast rendezvous running here on top. And then since between inner domain, it's non-fully matched, and we're just connecting to our between the rendezvous points within interdomain. So to illustrate the multicast boundary, we said we can configure that on what type of interfaces, the routed interfaces. This could be a routed interface. It could have been L3 lag. It could have been a point-to-point SVI or a sub interface, right? No problems as far as restrictions there. Now, solution 2, interop with PIM source specific multicast. Now, first thing first, if it's a purely, let me bring this up real quick too, because if it's a pure PIM source specific multicast network, there's no rendezvous point, right? So then you don't need the BSR boundary command because there's no need for the BSR boundary command. We said the BSR boundary command is to filter out the BSM messages, which is the rendezvous registration and announcement. In a source-specific multicast network, there's no RP. So then we won't need that BSR boundary command. We would only need the boundary ACL to filter which source or which receivers and so on, which sources of multicast we want to make available to the other group. But in a case where we have, of course, PIM works across the boundary, no problem, PIM source-specific multicast, and you don't need MSDP, right, if it was pure. But when you have a non-SSM flow in a network and an SSM flow, then you still need that MSDP, right? Because let's say one side you have RP rendezvous, and then on the other side is if it's a pure SSM, well, we still need MSDP to exchange in regards to source active source to be known on the other side. Let's make sure if I need to be aware of some chats here. All right, so let me bring this here. Solution 3, combining with VXLAN. All right, so key thing to note here, we do not support the BSR boundary and boundary ACL on the VTEP switches, right? So in this case, we have an edge device, and then in domain, let's say domain 2, to communicate between domain 2 and domain 1, which is basically we have our VXLAN running. The edge switch that is non-VXLAN, VTEP, will be configured with the BSR boundary and also with our boundary ACLs. And this is basically interop, as far as giving us interoperability with a VXLAN environment, if you may. So again, note BS boundary, BSR boundary, and boundary ACL commands are configured on the edge routing switch, not on the VTEP routing, right? So we do have the, of course, MSDP, but the commands are on a non-VXLAN VTEP edge switches. All right, so unsupported platforms. IPv6 PIM boundary is not supported, right, currently. And then PIM boundary interop with multicast over VXLAN is not supported, as we just went through. But there is that, this is a solution of workaround, if you may, right? We can still achieve that. So for the overlay, we can, but for the underlay, we can. Okay. All right, configuration. Looking at some of the new CL commands. Now, you have your IP PIM sparse mode BSR boundary, the IP multicast boundary access list, and then the show IP multicast boundary interface. Now, please note that just to make sure there's no confusion, right? Under the interface on the edge boundary, the command IP PIM sparse BSR boundary, what is it doing? It's basically filtering the BSM messages, which is preventing our rendezvous registration and announcement going across to the other domain, right? That's for the rendezvous announcements and registrations. Now, when the multicast stream starts, which streams of multicast we would allow to go across or which ones to filter, that's where the IP multicast boundary access list kicks in. This is the data plane, if you may, right? And this is the control plane, the top BSR boundary. All right, and we already spoke about what type of interfaces, right? The routed only ports, L3 lags, SVI, and point-to-point SVIs, and then of course sub interfaces. And the show IP multicast boundary interface command will show us the access list, that boundary access list we have configured, and all the filtering and drops of our BSM messages. So let's take a look at some configuration example. Deny all resources for groups in range of 239.0.0/8, permit other streams. Okay, so first we create our simple access list, right? Called it boundary 1, and we're denying any source and destination being 239.0.0/25.0.0, right? So only that /8, right? We want to deny that. And then here, line 20, remember, if you just have deny, there is an implicit deny at the end of this boundary ACL as well, right? It's an access list. So permit any source, and then basically all the other multicast groups, right? And now that we have our boundary ACL, we win, in this case, under the lag interface, you have, of course, the PIM sparse mode enabled, nothing fancy there. And then you have your IP PIM sparse mode BSR boundary. Again, this message is blocking the BSM messages to prevent the rendezvous points, registration and announcement across the domain, preventing that. And then the boundary IP multicast boundary access list boundary 1 command has been applied. Notice there's no in or out because it is applied for both direction, right? It's applicable for both direction here. All right, so, and that's basically our example 1 here. And then example 2 basically says, okay, permit a specific source and group traffic. And remember, there's an implicit deny all, right? Because we have permit, well, the implicit deny will take care of the others. So we're allowing a specific source and a specific multicast group, in this case, in or out, right? Because it's been applied. So same thing in here. BSR boundary command's been applied on that edge boundary routing switch, and the IP multicast boundary access list boundary 2. And in that case, we are only allowing those sources and that group to be allow in or out, outbound or inbound direction, both. Now, a new command was added. So this is a multicast source directly connected to VSX. And very important, right? So in an environment where you have the source, the multicast source directly connected to a VSX nodes, and you have Anycast rendezvous running, then it is important that you configure Anycast RP source directly connected on these devices, on the VSX nodes. So come on. So that's the settings. And here under router PIM, you enable Anycast RP source directly connected. Now, please note, right? This is not specific to PIM boundary, but it's more for MSDP requirements, okay? Because the source is known by both and you have the Anycast rendezvous running. So this is one of those commands that was added in 10.10 to support source directly connected to VSX nodes that are running Anycast rendezvous points. All right. Best practices. All right. Now, best practices, always use both BSR boundary and multicast boundary access lists to avoid rendezvous across the domain, right? Unless it's basically source-specific multicast only network, right? Or a single domain. So in a single domain, because we need the rendezvous to be known, for example, or in a source-specific multicast, there is no rendezvous point, then we don't need the BSR boundary command, right? The IP PIM BSR-boundary command. In that case, we're only going to need the IP multicast boundary access list, right? Well, what do I want to apply? So we have one domain and we're logically preventing certain multicasts. This could be a large university, right? In a campus that they want to prevent. Maybe within this campus, we want to allow all these multicast sources to be streamed, but for our extensions that we have, maybe we only want to allow this source or that specific source of, and this multicast groups. And then I can use that boundary access list. I don't need to, but they need to know about the rendezvous point. So the boundary access list needs to be reviewed carefully, right, by the administrator, because this defines, right, the traffic behavior. So it's critical, right, what do you want to allow. Remember, the access list is for inbound and outbound, both inbound and outbound direction. And also, please remember, there's, of course, in the ACLs, there's that implicit deny, right? All right. So then troubleshooting. With troubleshooting, well, some of the basics first, right? Of course, it would be best to have a topology. I should have had the topology here. Ensure, of course, the IP interfaces with the IP interfaces details are included, and physical cables, and generate your tech supports, all that good stuff. Well, from a troubleshooting point of view, if all the layer one has been taken care of, let's just say for sake of our conversation, then we use our show commands to validate, right? And then, of course, depending again on the experience and so on, when it comes to troubleshooting, how do you approach it? If I'm just basically, you know what, there's an option of basically top down or bottom up approach, and then divide and conquer. Well, with experience, we can say, you know what, based on certain things, I'm just going to go here and check these MSDP or take a look at that show IP multicast boundary interface, make sure that I do see some hits on those ACLs and so on. Or if I just need to start in general as a whole, if I can take a systematic approach to make sure, verify the data plane of multicast forwarding, right, routing tables, and the neighbors. So within each domain, assuming the multicast is forwarding appropriately and the PIM neighbors are good within each domain, then make sure of course, the rendezvous point, the rendezvous registrations, right, and advertisement and registrations are not exchanged, right? And I should be able to see that, right? And I want to make sure that my rendezvous points are not known to the other domain, right? That's the whole point of the BSR boundary command, to prevent that from happening. And then verify, oh, I've done that, but without MSDP. If I don't have MSDP, well, how am I going to exchange that information, right? How am I going to let the other domains know about the multicast source that I want them to know about, right? So I need to make sure my MSDP peers good, right? Peering is good between the domains, not only between, but also within if I have any cast rendezvous point, right? And so there are several commands here we can take a look at, right? And a good one, show IP MSDP summary, is a quick way of looking at our peers. And we'll take a look at those a little bit more detail. Well, I have the peers and stuff, and also I want to validate, is the valid source, my peer, maybe domain one, is it announcing that source active, right? The active source, basically source multicast across the domain to the other rendezvous points in other domains, right? That's where the show IP MSDP source active cache kicks in. And then, of course, we have the ACLs that we have defined on the interface. So again, these are nothing new, right? These commands you guys are pretty much familiar with, but just to kind of make sure that everyone is on the same page, show IP PIM neighbor. Quickly, we look at our neighbors, right, on the given interface, right? We have in this switch, we have our two neighbors, given our neighbors' IP address and how long they've been up and so on, right? And then show IP mroute, very important, our multicast routing. And then I see the multicast group and the source 20.1.22, right? From which neighbor, incoming interface important, and of course the outgoing interface is very important, right? For reverse path forwarding check is being done here. All right, and then of course the advertisements, we can see show IP PIM RP set in my domain. If I do that, I shouldn't, if I'm blocking those multicast the rendezvous points with BSR boundary, then I shouldn't know about the rendezvous points from other domains unless we're making specifically, if we're allowing for a specific source using MSDP. Show IP PIM BSR. So here we are, right? The bootstrap router, right? So on this switch, the BSR, and this system is the candidate BSR, okay? And this system is the candidate rendezvous point. And for which groups? So that would be our BSR. Show step number 3, verify the MSDP peer. You have two commands you can quickly for a specific peer, or the summary will show you all the peers, right? And you can see that source active counts, right? The peers up, that's MSDP peer, but the show IP MSDP summary command. Show IP MSDP peer 3.3.3. We can see that the peer IP address, right? It's how long it's been up, then the intervals, right? And of course, how many source active messages been sent. And it specifically show IP MSDP source active cache. So now this is important. If I need to see using MSDP, the MSDP is allowing for this source, this group, right? And the rendezvous and the peer that we learned from this multicast source and source and group. This is what we're making available to the other domains. And our new command, show IP PIM, show IP multicast boundary interface. So I can see my boundary access lists, right? And in here, I can see the packets and the counters, the drops and so on. So I can see there is basically the BSR and then the boundary ACLs being going in effect for me. All right, so then I'm going to hand over at this point to Daryl. Daryl, I'm going to stop sharing. Yeah?
Yes.
Okay, go for it, Daryl.
Okay. So this is my demo environment. So let me explain. On the left, I have a source, multicast source, that's streaming video out. Switch 1 basically is the BSR and RP for PIM domain 1. See here? I have this switch 2 that's connected to both domains. Also switch 3 in PIM domain 2. I have a receiver here, 30.11.21 connected to switch 3 in PIM domain 2. I'm going to show you before and after. So basically before, I do not have this boundary applied on this interface facing PIM domain 2 on switch 2. Right? So that means switch 1 will receive RP information from switch 3, which typically you do not want, because different domains, you want to have some limit, you want to maintain that each domain have its own RP. And we do not have the ACL applied as well. That means the video is being allowed, but you can control it if you want to. So let me show you the first thing here. This is the receiver. IP address is 30.11.21. And you can see it's receiving the stream 239.111. It matches here. This is the receiver unicast address, and it's also receiving the stream from the source. So let's check switch 1. We can see RP is actually learning RP from switch 3, and it's also a candidate BSR, right, and RP for itself. Data plane, you can see it's forwarding. S, G, source is 1.22, is the group 239.111. Incoming is VLAN 20, outgoing is 1150. It also matches the diagram. Source, outgoing 150. We check switch 2. We should see something similar. See, it's learning the RP information from switch 3 in domain 2. We look at data plane, S, G, source, the group, incoming is 113, outgoing is 111, and that matches as well. Finally, let's check switch 3. So switch 3 will be the RP for itself. And from data plane perspective, you can see S, G, the same, source and group, incoming is 150, outgoing is VLAN 30, and that matches the SVI for this receiver. Okay. So next, let's apply the ACL on switch 2, this interface facing domain 2. Switch 2, you see I have an ACL here. I basically deny whole range. So once I apply it on interface, one-on-one, this video will stop working because we have ACL in effect, enabled. So let me do that. Let me enable that on interface. Okay. Here, I'm going to apply it. You see the video is working right now. Let me apply it. And after some time, you see stop working because your ACL, your boundary ACL is working. In effect, and the show IP route, M route, there's no longer a stream working. There's no outgoing interface because it has stopped. It's been denied. So what we can do is actually modify if we want to allow the stream from work to work like this. I insert a entry number, rule number 10 to allow a specific source for going through. Okay, so I'll do that. Modify it. Now 10 has been allowed. It'll take some time for the stream to work. It still doesn't work here, right? You see. So while we're waiting, let's check a few other things. Here, Emerald doesn't work as expected. BSR is still showing 3 as the RP after some time because we're blocking the RP information. So switch 1 should be the RP for domain 1. Switch 2, okay, see now the stream is finally working. We check. The stream is now forwarding. Okay. Switch 2 as well, you can see forwarding. Outbound interface 111. So let's check the RP information again. It's still showing the RP from domain 2 as the RP. It's the BSR. So that's not what we want. After some time, it should reflect this switch 1 as the BSR and RP. Okay. It takes some time, but we should see it soon. So you can see now, BSR. It is showing correctly. So domain 1, switch 1 is the BSR. Same for here. Switch 2 is showing BSR. So we can check RP as well. After some time, it will show. So basically, we blocked, right, using the ACL. We've split up the domains to ensure switch 1 doesn't get the information from switch 3. Okay? We also blocked data plane perspective, the video, but we also permitted if we wanted to. So you can see the ACL is working as expected. Okay? So if that demo is done, let's go through the resources. Some resources, some links for you to read up on BSR, MSDP, and multicast addresses. Thank you.